Good morning. This week we are going to look at the periodic table, which is basically just a chart that organizes all of the elements that we know into some kind of cohesive and easy to understand way. In 1869, a Russian chemist, Dmitry Mendeleev, created the framework for what would become our modern periodic table, that which you can see before you. He actually left gaps when he created and started to organize this for elements that had not yet been discovered, but he kind of assumed what existed in some way, shape, or form based on how he organized that periodic table. While he arranged the elements according to their atomic weight, if he found that they did not fit into the group, he would rearrange them, and he would predict the properties of some of those undiscovered elements and gave them names. Even though some of his predictions were not actually accurate, once we learned more about some of the elements as we moved forward or discovered more elements, his ideas and his organization again is going to be the framework for what we now know about the periodic table.
All right, so let's look at what we can tell about the periodic table. Look at how it's organized and some things that the way it's organized can tell us about particular elements. We're going to start with looking at horizontal rows. So let's going this way. So hydrogen and helium, right, would be one horizontal row. This would be another horizontal row. These horizontal rows are called periods. And there are 7 periods. We label them 1, 2, 3, 4, 5, 6, and 7. So this would be going that way, going this way. And periods can tell us really important information because each element, depending on what period it is, its period tells you how many shells there are. So for instance, hydrogen has 1 electron shell. Okay. Lithium, beryllium, they have 2 electron shells. Oxygen has 2 electron shells. So remember when we went back to that other lecture video about how electrons are organized, here's the nucleus, and then you had a shell here, right? And then N equaled 1. So this would be helium and hydrogen, or helium and hydrogen. Then you had another shell, then you had another, and we only really diagrammed 4, but know that there are a total of 7 shells. So the periods can tell us how many shells are in an electron. And these are our horizontal rows. Now let's look at going up and down. Going up and down in columns, we call these groups. Okay, so groups are vertical rows, and these are going to be important because they're going to be organized based on the number of valence electrons. Now there are 2 ways that we label row or groups on a periodic table. The first way is just like periods going all the way across. So this would be group 1, this would be group 2, this is group 3, group 4, group 5, 6, 7, 8, and this is how they're labeled on your periodic table. And there's 18 groups, right? So there's 7 rows, there's 18 groups. Now, we also are going to kind of sub-label these groups in a different way that's going to indicate the number of valence electrons. So I should have maybe written that in green. But I'll show you how that would be. So this would be 1A, this would be 2A, then we would go all the way across. We're basically going to skip this whole middle section of these transition metals. We'll talk about that in a second. So this would be 3A, 4A, 5A, 6A, 7A, 8A. So by looking at, like, for instance, 1A has 1 valence electron. 7A has 7 valence electrons. And these we would actually, they do these again, but they would do B. So this would be 3B, 4B, 5B, 6B, 7B. And you will have to write these ones in because they are not written on your periodic table. 11b and 12b. Okay, so periods go across, groups go down. So again, if we kind of just draw this down here, that is a group. Groups and periods.